Welcome to this FP2 video on the exponential form of a complex number or complex numbers. Now, in FP1, we looked at using the modulus argument form of a complex number, and that was when z is r brackets cos theta plus I sine theta. Okay, where r was mod z and theta was the argument of z. Now this is in FP1 unit 1.6 if you want to refresh your memories on this, and 1.5 was finding r and theta for the modulus argument form. So that is, just previously. I'm not going to re-go over it. You can look that back up. Now, what we want to be able to write this is in exponential form. So we're going to write it as r e to the I theta. Okay? And that's what we're going to do. Now, part of this understanding isn't going to come now, because cos theta can be written as an infinite series of powers, and it's this. So 1 minus theta squared over 2 factorial minus plus theta to the 4 over 4 factorial minus theta to the 6 over 6 factorial, and so on, all the way up to minus 1 to the power r theta to the 2r over 2r factorial, and it does keep on going. Okay, now this is something that's going to appear in the Maclaurin series. So we're looking at the Maclaurin series much later on in this series of videos. It's unit 7, this is unit 3. So there is going to be, a little bit of time until we get there. So that's when you'll understand where this comes from. But until now, you're just going to have to take my word for it, I'm afraid. So sine theta is this. I'll just put it down now. And here it is. So basically speaking, the cos theta is going to be the even powers. The sine theta is going to be the odd powers. But again, we'll look at that, how we get these values, how we get this series when we get to unit 7 and look at the Maclaurin series. Now, let's take this another step further. So before we get to, finding this, we first need to look at what the series is for an exponential. So for e to the x, it's going to be 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4 over 4 factorial, and so on. So x to the r over r factorial. Okay, so that's what happens there. So now let's look at what happens when I have e to the I theta. Okay, so e to the I theta is going to be 1 plus I theta plus I theta squared over 2 factorial plus I theta cubed over 3 factorial plus I theta to the power 4 over 4 factorial, and so on. So all I'm doing here is substituting the I theta in for the x for this above series expansion. Now, when I simplify this, so, if I first look at writing this. So I've got 1 plus I theta. Now, I squared is going to be minus 1, isn't it? So this is now minus theta squared over 2 factorial minus I theta cubed over 3 factorial. Now, it'll be plus because I to the power 4 is plus 1. So that is theta to the 4 over 4 factorial. And we can keep going. Theta to the 5. So it'll be I theta to the 5 over 5 factorial. And then when we get to the 6, it's going to become a minus. And so on. Okay, so that there is just looking at the powers of I. So remember, for every 2 powers of I, so 2, 4, and so on, you get that minus 1. So that's what, gives us the sign changes as we go through it. And what we can do from this series is split it up, because if you look at here and you look at this one and this one, we effectively do get this series. So it would actually split up into 1 minus theta squared over 2 factorial plus theta to the 4 over 4 factorial plus, minus theta to the 6 over 6 factorial, and carrying on. Plus, and then if I take the I outside, I'd have theta minus theta cubed over 3 factorial plus theta to the 5 over 5 factorial, and so on. Okay, and this here is cos theta and this is sine theta. So this is cos theta plus I sine theta. Okay, so that's what e to the I theta is. So e to the I theta is just cos theta plus I sine theta. So that means that then we can go from our modulus argument form and this cos theta plus I sine theta can be replaced with this. So e to the I theta. So that's where it comes from, where r is, as we said, mod z, and theta is argument of z. So this now is the new form. Okay, and this is how we do it, but obviously where these come from you'll learn later on, so don't worry too much about that now, or even really where this comes from. It's just there as just a little guide. So more importantly, now we need to look at how we can switch between the different forms. So I've got a few examples for you, I think 4 or 5 examples showing that, and then there'll be questions at the end as always. So here I have expressed in the form re to the I theta, where theta is between minus pi and plus pi, and that is generally the case for all of these. So we get z equals, so root 5 is my r, and I've got e to the psi I, and then it's pi by 6, because theta's pi by 6 in both of these, and that is just set out the same. So that one's nice and easy. Now b, we've got a little bit of a problem. We've got a minus sign here. So first of all, I need to change that. So if I go z is 8. Now if I change my angle to a negative angle, I get cos minus pi by 12. And then this one will go to a positive I sine minus pi by 12. Okay, now cos of minus pi by 12 is just exactly the same as cos of pi by 12. The negative angle and the positive angle are the same. And that, you know, we've done kind of going all the way back to GCSE. You should know that and think about it from your cost diagrams. Okay, but with the sign changing the angle to negative would change the whole thing, because, you know, sine of minus theta is equal to minus sine of theta. Okay, so these two things are interchangeable. So that's what I do there, change it so it works in the same form with a plus here, and then I've got my form, so it's 8e to the minus I pi over 12. Okay, so that's now the second one, and that's in the correct form. Nice and easy so far? Yeah, I think so. Let's look at the next example. So now I've got z is 3 minus 2i. So 3 minus 2i is going to be going this direction, 3 across, and then 2 down. This is going to be my r, and this one will be alpha. Okay, and that is z equals 3 minus 2i. So let's work out r. So r is that mod of z, which is 3 squared plus 2 squared square rooted. And that is the square root of 13. Then I want to find alpha first of all. So alpha is the inverse of tan, and tan is opposite over adjacent, so 2 over 3. So in radians, that is 0.588. Now, the argument of z, remember, goes positive direction, negative direction. So this angle is going to be the negative answer. So theta is minus 0.588. And of course, this is the three significant figures. Okay, so now I've got everything, I can go ahead and say my form. So z equals root 13 e to the minus 0.588i. Okay, just remember that theta is in radians. But yeah, there we have another simple conversion into this form. Right, let's move on to the next example. So the next two examples, we're going to be going in the opposite direction, starting off with the exponential form, and this time putting it into the form x plus iy. So from this, we can say that r is root 3 and theta is pi by 3. So obviously, as a sketch, that's going to be looking like this, where this is root 3. So of course we could work out these values from our sketch, but it's easier to use the modulus argument form. So that's root 3 cos pi by 3 plus I sine pi by 3. And that gives me root 3 is half plus, and then this is I root 3 over 2. So this gives me root 3 over 2 plus 3 over 2i. There we are. So this is now in the form x plus iy, or yi as I've written it. Okay, so that's converting it from exponential into, this form, x plus iy. Now let's look at converting it just into the modulus argument form, and the reason I show you this one is the angle size. Okay, so we've got that r equals 5 and theta equals 24 pi over 5. Now this angle is not in the range between minus pi and pi, so what we must do is keep subtracting multiples of 2 pi until it appears in the range. Okay, so if I subtract 2 pi from this, I got my 24 pi over 5 minus 2 pi. That gives me 14 pi over 5, which then I subtract 2 pi from, because it's not in the range, and I get 4 over 5 pi. And that is in the range now, okay, which is in the range minus pi and pi. Okay, so now it's in the range, we can say what z is. So z is equal to 5 brackets cos 4 over 5 pi plus I sine 4 over 5 pi. Okay, and that is how we write it in that form. So we've got to be careful with the angles, because we're basically finding equivalent angles, but that are in the form or in the range between pi and minus pi. So this final example is just an example on just manipulation, okay, which sometimes you do have to do for part of a question. So it gives me that e to the I theta is cos theta plus I sine theta. And there in the brackets is e to the minus I theta. So let's look at that, e to the minus I theta. So that is e to the I times minus theta, which is cos of minus theta plus I sine of minus theta. Now, cos of minus theta is the same as cos theta, and sine of minus theta is the same as minus sine theta. So we get that it's equal to this. So e to the minus I theta is cos theta minus I sine theta. Now let's look at this. So we'll start with this side. E to the I theta plus e to the minus I theta. So that's going to be cos theta plus I sine theta plus cos theta minus I sine theta. So these two are going to cancel the I sine thetas, and it's going to leave me with 2 cos theta. So e to the I theta plus e to the minus I theta is 2 cos theta. Then if I multiply this by a half, e to the I theta plus e to the minus I theta, then it's going to be a half times 2 cos theta. And the halves are obviously going to cancel, leaving me with just equaling cos theta. So hence cos theta equals a half e to the I theta plus e to the minus I theta. Okay, so that's just something that we will use, in questions, but just for now, it's just a practice on manipulating, okay, these things. So there's all the examples in today's video. Before we get into the questions, just want to remind you to like the video if you found it useful so far, subscribe if you're yet to subscribe, and if you're willing and able to help me out financially, please hit that join button. Otherwise, let's look at the questions. So 4 questions for you. So it's converting these into re to the I theta, and then converting from the exponential form into x plus I y. Okay, then looking at ones where the angle is outside of the range, and then finally, like the final example, just a manipulation question. So pause the video now. Welcome back. So hopefully you've had a go at these and you've had no problems, but if you had, or you just want to check your answers, let's have a look at the solutions. Okay, so let's do part A. So minus 5 is, let's do this in red so it shows up. This direction, isn't it? 5. And this is the angle. This angle is pi. So this will be z equals 5e to the I pi. Let's look at B. So again, a little sketch, and then I'll draw this on in red. It's going to be straight up, is there 8 in the imaginary direction. Okay, and this angle here is going to be pi by 2. So z equals 8e to the pi by 2i. You can put the I in front of the pi by 2 or after the pi by 2, is totally up to you. Okay, let's move on to C. So 3 minus 4i will be down here somewhere. So 3 across, 4 down. I'll work out that alpha as well. So let's work out R first. It's mod z, which is the square root of 3 squared plus 4 squared. And that is going to be 5. And then alpha is arc tan opposite over adjacent, which is 0.927 to 3 significant figures. That means theta is minus 0.927 to 3 significant figures. So z is 5e to the minus 0.927i. And this is simply z equals root 5e to the 3 pi by 4i. And then e, we've got that z equals 4 cos pi by 3 minus I sine pi by 3. Now changing these to negative angles will change this to a positive. So that means that z is equal to 4e to the minus pi by 3i. Okay, because we want a positive in here. So there we have the first question done. Hopefully you had no problems there. Let's look at number 2. Okay, so A is obviously e to the pi by 5i, which becomes cos pi by 5 plus I sine pi by 5. And cos pi by 5 is 0.809 plus 0.588I, correct the three significant figures there. So that was just part A. Now part B is Z equals 2e to the pi I, which is 2 times cos pi plus I sine pi. Now cos of pi is -1 plus I, and sine of pi is 0. So this is going to be -2. Now let's look at C. So we got root 2e to the minus pi by 4I. So that is going to be root 2 to the cos of minus pi by 4 plus I sine of minus pi by 4. So that's root 2 to the cos of pi by 4. We don't have to do this step, sine pi by 4. But I'm just changing them into their positive versions there. So root 2 is times by 1 over root 2. Obviously, if you did this in your calculator, you'd get root 2 over root 2. Okay, which when you multiply by this, you'd end up with the 2 over 2 root. You'd end up with 2 over 2. So it would still cancel out the same. Now sine of pi by 4 is also 1 over root 2. So that's going to be 1 minus 1, which is going to be 0. I probably should have checked the answer to that one before I set it as a question. But hey, there we go. That one's just actually 0. Right, let's move on to question 3. So this one we need to put into modulus argument form, but we've got angles that appear outside of our range. So r equals 1 in this case, and theta equals 15 over 8 pi. So we need to take away 2 pi from it. So 15 over 8 pi minus 2 pi is minus pi by 8. So z equals cos of minus pi by 8 plus I sine minus pi by 8. And I don't need to change the signs within here. Okay, we'll just leave it like that. That is now between pi and minus pi. So that one was A. Let's now look at B. So we got z equals 5e to the minus 10 pi over 9I. So r equals 5, and currently theta equals minus 10 over 9 pi. And 10 over 9 is obviously bigger than 1. So this is outside of the range. So this time, instead of subtracting 2 pi, we're going to add 2 pi. And that's going to give me 8 over 9 pi. And now that is within my range. So z equals 5 brackets cos 8 pi over 9 plus I sine 8 pi over 9. And there we have question 3 complete. Final question. So first, like the example, we want to start off by working out e to the minus I theta. And we've already done this once, so this step is the same as in the example. Okay, there we have it. So now let's start with e to the I theta minus e to the minus I theta. So that's going to be cos theta plus I sine theta minus cos theta minus I sine theta. So cos theta and minus cos theta will cancel, and then this I sine theta will become positive. So we're going to be 2I sine theta. Okay, so that's what I've got. So now 1 over 2I times by e to the I theta minus e to the minus I theta will give me 1 over 2I times 2I sine theta. The two i's will cancel, so that equals sine theta, which is what we've got. So therefore, sine theta equals 1 over 2I e to the I theta minus e to the minus I theta. As required. And there we have it, the first video on this complex numbers unit. Bit of conversions. Hopefully you found this useful. You do have to be comfortable converting between various forms within complex numbers. And you might want to refresh some of your complex numbers from FP1 or go back and have a look at my previous videos on the complex numbers of FP1, because a lot of that will be coming up in this unit, and obviously I'll be assuming that you're all very good with that. Okay, so stay tuned for the next one where we look at multiplying and dividing complex numbers. Otherwise, I hope you found this video useful, and don't forget to like, subscribe or join. See you in the next one.